Lesson 14.2, Task 4, Recursive Formulas for Geometric Sequences. Write recursive formulas for geometric sequences. Write a recursive formula for the geometric sequence with a2, your second term is -10, and a sub 5, or your fifth term, is -80. Find the common ratio r because 5 is -2 equals 3. It follows that. All right, so let's look at this for just a second. All right, so we are given our second term and our fifth term. We know that those are 3 terms apart. So we're going to take what we're given and we're going to say our second term times our common ratio 3 times, because from 2 to 5, that's 3 times, so r to the third power equals our fifth term, okay? So we're going to take -10 and substitute that in for our second term. And a sub 5 is -80. That's given information here. All right, so if I divide both sides by -10, that gives me 8. And then if I do r cubed, I have to do the cube root to undo something cubed. And that gives me r is 2. All right, so in your calculator here, if you don't know what the cube root of 8 is, or if it's something bigger than 8 and you need to know what it is, you can click on Math, and cube root is right here. So the cube root of 8 is 2. And the reason the cube root of 8 is 2 is because 2 to the third power is 8. So a cube root and something cubed, those undo each other. Okay? All right, so it says find the common ratio, r, and then that's what we did. When you solved for r, you found the common ratio. And it says because 5 minus 2 is 3, and the reason they did that is just looking at the difference in terms. There's a difference of 3 there, and that's why you started with r cubed. All right. It says, why can you find the fifth a sub 5 by multiplying a sub 2 by r cubed? So you go from one term of a geometric sequence to the next term by multiplying by the common ratio. Since the fifth term is 3 terms from your second term, you need to multiply a sub 2 by r to the third power. Or you could multiply by r times r times r. And remember, r to the first times r to the first times r to the first, same base, you add exponents, it still comes out to be r cubed. All right, so it says, which statements help explain why your second term is 2 times your first term? All right, so the sequence is geometric, not arithmetic. You multiply by a common ratio. We know it's geometric. So your common ratio is 2. If it's arithmetic, it would be a common difference. Any term in the sequence can be adding. No, any term can be found by multiplying the previous term by the common ratio. So there's 3 correct answers there. And then it says find the first term, a sub 1, because a sub 2 equals 2 times a sub 1, or -10 equals 2 times a sub 1. It follows that a sub 1 is -5. So all they did was plug in information they already knew to find their first term. So therefore, a recursive formula for the sequence is a sub 1 equals -5. Remember, for a recursive formula, you have to have your first term. And then your general formula is a sub n equals 2 times a sub n minus 1, or your previous term. All right, that's all for task 4. If you have any questions, let me know. Lesson 14.2, task 5. Translate between formulas for geometric sequences. Given an explicit formula for a geometric sequence, you can write a recursive formula and vice versa. The table below shows how to translate between these 2 representations of a geometric sequence. All right, so this is good information to have in your notes. This shows you function notation for both explicit and recursive, and subscript notation for both explicit and recursive. You can see these are very similar, a sub n and a sub 1. and a sub 1 here and a sub n here. So subscript notation, very similar to function notation, except this one's just written as a function. A of n equals a of 1. So instead of a sub n equals a sub 1, it's just written in function notation. Same thing here with recursive formula and subscript notation. All right, write an explicit formula for the geometric sequence defined by the recursive formula a sub 1 equals 7, so my first term is 7, and a sub n equals 4 times a sub n minus 1. So I've got a first term of 7, and I've got a common ratio of 4. Substitute these values into the general formula of the explicit formula for a geometric sequence. All right, so our general formula, a sub n equals our first term times r to the n minus 1. So plug in 7 for your first term, 4 for your common ratio, and that gives you an explicit formula. A sub n equals 7 times 4 to the n minus 1 power. All right, so how can you check that the explicit formula gives you the correct first term? All right, so we're going to substitute 1. We're looking for our first term. So we're going to substitute 1 for n. N, we're looking at the explicit formula. And the result should match the given first term, which we already know the first term is 7. All right. Nicholas says that the explicit formula should be a sub n equals 4 times 7 to the n minus 1. What mistake did Nicholas make? All right, so I think he reversed the first term and the common ratio. So see, it's 7 times 4. He has 4 times 7. So he reversed the first term and the common ratio in the explicit formula, which is what we've been looking at. All right, that's all for task 5. If you have any questions, let me know. Lesson 14.2, task 6. Translate between formulas for a geometric sequence. Write a recursive formula for the geometric sequence defined by the explicit formula a of n equals 10 times negative 6 to the n minus 1 power. Find the first term of the sequence. A sub 1 equals 10 times negative 6 to the 1 minus 1. So they just substituted the first term, n for n, and then n minus 1 would be 1 minus 1 here. So that's going to give us 10 times 1, because anything to the 0 power is 1. Properties of exponents, 10 times 1 is 10. So our first term is 10. And then to find the common ratio is the base of the power in the explicit formula. So negative 6 is my base to the power. So negative 6 is automatically my common ratio. So a recursive formula for the sequence is a sub 1, my first term is 10, and a sub n equals negative 6 times a times n minus 1, or your previous term. What is another way you can use the explicit formula to find the common ratio? All right, I could use the explicit formula to evaluate the first two terms and find that a sub 1, our first term, is 10, and a sub 2, if we plugged 2 in, you would just put a 2 in here. 2 minus 1 is 1, and so that would be negative 6 to the first power, and then negative 6 times 10 is negative 60. So that would give us negative 60 for our second term. And I can find the common ratio by dividing my second term by my first term. So this would be dividing. To get negative 60 divided by 10 is also negative 6, which we can see is our common ratio from the formula above here. All right, but this is just another way you can use the explicit formula to find that common ratio. All right, it says this one's wrong. I can find the common ratio by, I don't know if they want divide or negative 60 divided by 10, but that should be some form of dividing, should be the correct answer there. You always divide the first term by the second term. All right, so how can you check that the recursive formula is correct? Well, you could use the explicit formula and check a couple of the terms by plugging numbers in to see that you get the same number. Remember, the recursive formula and the explicit formula should give you the same answer. They're just evaluating two different ways. All right, that's all for task 6. If you have any questions, let me know.